Alrighty then, corn children, children of the corn, the highly anticipated YouTube video on U substitution technique of integration. Woo! All right, here we go. Clearly, this problem is not a basic integration form. It's a quotient. We have all kinds of crazy things happening. So the goal is to substitute out all of the variable x, this x, that x, and even the dx. Rewrite the problem in a different variable and in a different way that turns it from something we do not know how to integrate into something we do know how to integrate. All right, the first thing we need to do is we need to choose a u. I am seeing, I am noticing that x cubed plus 1 is inside the radical and inside the denominator. Our choices of u substitutions are often, not always, often chosen by letting u equal the inner function. I have here written down that u can substitute in for x cubed plus 1. Now we will know if this is a good idea when we take the derivative and then look and see, are we able to substitute out all the x variables? So I'm going to take the derivative. I'm going to do this nice and slow. When I take the derivative of u with respect to x, it becomes du dx. When I take the derivative of this side with respect to x, I get 3x squared. Now, I am going to get the du alone, separating the variables, by multiplying by dx on both sides. So here's what I have now. Du, 3x squared dx. And this makes me so happy. I'm so happy. Why? Why is she so happy? X squared dx? Look at the original problem. X squared dx. Yes, I know that's not in the numerator, but dx can be written as a fraction and pushed into the numerator. X squared dx, x squared dx. So happy. The 3, not so happy. But it doesn't horrify me either, because 3 is a scalar. It is a number multiplied by. And in this equation, I can divide both sides by 3. This is, of course, the same as 1/3 times du. Alrighty, now, it is time to take all the x's out of the problem and replace them with all the u's. Ready? Go! Here we go. This integration problem, let's slide it over, will turn into the integral of. Down here, we have the square root of u. X squared dx, x squared dx. I can take all of this out and replace it with 1/3 du. I'm going to skirt the scalar, and I'm going to, instead of putting the du up here, I'm going to write 1 du, just so it looks friendlier. How's that going? Well, how is this better? This is a power rule. What? Yes, it is. It's a power rule in disguise. Isn't a radical the same as a 1/2 power? Wouldn't a negative exponent have sent it to the denominator? Yes, and yes. So this becomes u to the negative 1/2 du. Oh, it's so cute. I could pet it. Now we just integrate. It's that straightforward. 1/3 is the scalar. Integrate up, I add 1 to the exponent, making it a positive 1/2. The rule is then to divide by the exponent, multiply by the reciprocal, plus c. The scalar is now 2/3. I do need to return to the original variable. We started in x, we will end in x. So instead of writing u to the 1/2, also known as the square root of u, I will write the square root of x cubed plus 1 plus c, the constant of integration. And there, ladies and gentlemen, is u, substitution. Booyah.